Applications of quadratics. For the warm-up, match the following. Let's say you wanted to find the highest or lowest point in the graph. Would you do that factoring and using zero product property? Would you do that using quadratic formula? Or would you find the highest or lowest point by doing opposite b over 2a, then plug in and solve for y? And then likewise, when you want to find something that hits the ground, how do you solve? Factoring in zero product property, quadratic formula, or x equals opposite b over 2a, and plug in and solve for y. So try to think of what it's asking for. Is it the vertex or the x-intercepts? And the first one, you're trying to find the highest or lowest point. That's the vertex. And to find the vertex, you could graph it. If it's in vertex form, you just take a look at the opposite of what's in the parentheses. And then the number on the outside is the same. Or we've been looking at another way to find the vertex is opposite b over 2a. To find the x value, and then to find the y value, just plug in your x value, solve for y. When you want to find when something hits the ground, those are the x-intercepts, or the zeros or the roots. And to find the x-intercepts, you can factor and use zero product property. You can also use quadratic formula. So let's practice using those. So identifying what to use and how to use it. So here's the first example. Landon jumps off a cliff into the water below. The height he travels can be represented by this function where t is time in seconds and h is height in feet. And what height did Landon jump from? And so the starting height would be at time 0. If we plug in a 0 for time, we can see that, again, when we're plugging in a 0, anything times 0 is 0. So it's going to cancel a lot of these terms here. And the starting height then would be the 480 feet. So the nice thing about standard form is that last number, if it's in standard form, is the starting value, the y-intercept. So we can say the height at time 0 is 480 feet. Next question, what was Will's, well, it should be Landon's, height after 1 second? So same idea as before, we can plug in a 1 for time. You can type that into your calculator, and we can see what his height is after 1 second. And so what happens when you plug that in is we also get 480 feet. So we can draw a picture of what that might look like. So here's your cliff, here's the water below, here's Landon. All right, so he's going to jump, and this is 480 feet. He'll jump up, and then he'll go down, hit the water. And so this is 400, this is at time 0, you're 480 feet up, and this is 1, 480 feet. So we know that it takes him less than a second to hit his maximum height. And you can make a prediction of what that's going to be right here since this is symmetric. It's going to be in between 0 and 1 second, which is 0.5 seconds. But to mathematically show that it's indeed half a second to reach its highest point, that's the vertex. And the x value is opposite b over 2a. So in this case, the b value is 16. So we have negative 16 over 2 times negative 16, which is 1/2, or 0.5 seconds. Okay, but we knew that from using the symmetry of the graph, but how do we find the height? Like, how high did he actually jump up? And so then you're going to plug in and solve for y. So this was step 1 right here, to find the vertex opposite b over 2a. But step 2, I'm going to do my work right here for step 2, is we're going to plug in his height. To find his height at 0.5 seconds, we'll plug in the 0.5. So this is negative 16 times 0.5 squared plus 16 times 0.5 plus the 480. And when you do that, his height at 0.5 seconds is 484 feet, which means he jumped 4 feet into the air before starting his descent. So the vertex, again, the x value, in this case it was time, is opposite b over 2a, and then you plug in that time to find the height, the maximum height for the vertex, which ends up being 484 feet. Our last question is, how many seconds did it take for Landon to hit the water? So now we're talking about an x-intercept. So that point right there, we can see that there's going to be another x-intercept. If this is our axes right here, we can see that one answer will be negative and one will be positive, so we'll take a look at the positive answer. So I'm going to erase my work for this, give myself more room. And again, if it's an x-intercept, we can use quadratic formula to solve. So if we do that, x equals opposite b plus or minus the square root of b squared minus 4 times a times c. And it's all over 2a. Make sure I plugged in right. And then I'll ask you to calculate these three numbers right here. The discriminant, first number, the last number. So x equals negative 16 plus or minus the square root of, let me type that in. Okay, so that discriminant is 30,976. And that's all over negative 32. Now you can type that into your calculator and get your two different answers. And so one answer, negative 16 plus the square root of that discriminant, divided by negative 32. So one answer is negative 5, and the other answer is 6. So again, we can see why there was a negative answer. It's because he started at a height above 0. And so when you draw that parabola, you'll see the negative answer. But we're looking for the positive answer. It takes him 6 seconds to reach a height of 0 again. So 6 seconds to reach the ground. Okay, let's take a look at another example. Example 2, a company sells fidgets. The amount of profit Y made by the company is related to selling the price of each fidget, X, by the given equation. Using this equation, find out what price the fidgets should be sold for the company to make the maximum profit. All right, so the price, again, maximum. You're thinking vertex. And if X is the price of the fidget, X will be opposite B over 2A. So we plug in negative 72 over 2 times negative 1, and that ends up being an expensive fidget. The company should sell it for $36. When they do, they'll make the maximum profit. But we have to figure out what that maximum profit is. So now we plug into the equation, the y equals, and we'll plug in a 36 everywhere we see the x. And let me type that in. The negative parentheses 36 squared plus 72 times 36. Whoopsies. And then minus 458. All right, so it ends up being, if they sell their fidgets for $36, they'll make a maximum profit of $838. If they sell it for any more or any less than that, they'll make less of a profit. Okay, so your assignment today is on Delta Math. It's called Day 18, More Applications of Quadratics.